The Verhoeven model for population growth specifies the reproductive rate of an organism as a function of the total population according to the following formula. RP equals R over 1 plus Kp, where P is the total population in thousands of organisms. R and K are constants that depend on the particular circumstances and the organism being studied, and RP is the reproduction rate in thousands of organisms per hour. If K equals 0.125 and R equals 45, find R prime of P, then R prime of 4. Interpret the result. K and R are constant, and so we would rewrite this equation as R of P equals 45 over 1 plus K is 0.125 P. Note that the independent variable for this function, or this is a function in terms of P. P is a variable, and K and R are constant. And so that is why we can replace K and R into this equation. But we cannot replace P equals 4 into this unless we're asked to evaluate the reproduction rate in thousands of organisms per hour. We are not asking for R of 4, we ask to find R prime of 4. What that means is that we would need to first find the derivative and then substitute 4 into P in the derivative function. We recognize that this is a quotient with the top over the bottom, and so using the quotient rule, R prime of P is we first square the denominator, 1 plus 0.125 P, and then we square this. In the numerator, the derivative of the top, the derivative of 45 is 0 times the bottom, 1 plus 0.125 P minus, and then we keep the top, which is 45, and we multiply the derivative at the bottom. The derivative of 1 is 0 plus the derivative of 0.125 P with respect to P is 0.125. This is minus 45 times 0.125 over 1 plus 0.125 P squared. We cannot combine this one with this 0.125 because they are not like terms. This 0.125 is not by itself. It belongs to the second terms. And these two terms, 1 and 0.125p, are not like terms, so we cannot lump them together. There's no need to simplify this because we're going to use the calculator anyway, but if we are asked to find a formula for R prime of P, then it is a good idea to simplify this. Most likely, we only need to simplify the numerator. If we take negative 45 times 0.125, we will get negative 5.625. Leave the denominator alone in the squared form. We rewrite the denominator. This is R prime of P. R prime of 4 is therefore negative 5.625 over 1 plus 0.125 times 4 squared. Use a calculator. We compute that this is negative 2.5. The unit for R prime is in thousands of organisms per hours per thousand of organisms. This is the units of R itself is already in thousands of organisms per hour over the unit of P. But the unit of P is thousand of organisms. So how do we interpret this result? We have to include this input and we have to include the result. The unit for this input, P, is in thousands of organisms. So we would say that at the current level of 4,000 organisms. Again, we have to include the input in the interpretation. The interpretation is about R prime, which is the reproduction rate. And since this output or the result is negative, we would use the term decreases by 2.5 thousand, which is 2,500 organisms per hour, and then per thousands of organisms. Now the units is a little bit strange here, but we have to include thousand of organisms per hour, which is the unit for R, over the unit of P, which is also thousands organisms.